Good morning, everyone. Thank you for giving the opportunity finally, and we all know we have done the poster session already, anyway. I'm Jyoti Narang. I'm a PhD student at Universitat Pompeu Fabra, Barcelona, Spain. I work under the guidance of Dr. Xavier Serra, and this work is done in collaboration with Dr. Marius, Miron, and Ajay Srinivasamurthy. So the topic is analysis of musical dynamics and vocal performances using loudness measures. As the name suggests, we are trying to analyze musical dynamics and vocal performances. So the overall goal is to develop a systematic methodology that can identify musical dynamics in a performance. So given an audio file, can we develop a system through which we can automatically categorize musical dynamics like piano, pianissimo, forte, fortissimo, and so on. So these 8 levels can be automatically categorized. So this work is part of this overall goal that we are trying to address as part of my PhD. And in this particular work, we focus on using loudness measures to compare student recordings with reference or teacher recordings. So something like this, wherein we are relating this measurement of dynamics to comparison of loudness features. So what we say is when a student is doing a performance, is imitating a performance, the dynamics are also imitated in the process. So if the dynamics are imitated in the process, using the basic traditional signal processing approach, what we would do is extract the loudness feature from the student recording, extract the loudness feature from the reference recording, do a performance level measurement, and which can eventually be used for providing feedback. So one thing that I forgot to address is like offer feedback. We are looking at it from the context of music education. So in the context of music education, there is feedback right now in the current systems like musician and so on. There's feedback that's provided on pitch and rhythm, but very limited feedback is given on the lines of expression, and dynamics is one of the expressive categories for which we are trying to develop a methodology to provide feedback. So as I said, we need, in this particular task, in this particular research, we were trying to use loudness metrics to do the comparison. And loudness metrics, something that's inspired by perceptual phenomenon. So we had a small talk that we can combine some models and so on, musicological models and so on. But then at this point, we were trying to use the Sohn scale that's more inspired by a psychoacoustic phenomenon to do a comparison of student recording with reference recording. This, as I said, work is in continuation of our previous work, wherein we were comparing the loudness curves. So the first, once we had this idea, the first task was, can we really compare the loudness curves? Is this expressive feature really comparable? So in our previous work that we published at CMMR, we derived. This is using Sohn scale. So the blue curve indicates the raw loudness values. The orange one is the smoothened curve. So we compare these loudness curves of professional renditions with source-separated vocal renditions. For more information of source-separated renditions, we'll talk in the poster. But then just the takeaway from this slide is that it is indeed possible to compare the loudness curves, and that can sort of show the musical dynamics comparison. So what happened here? So keeping these goals in mind, what we further did in this particular work was we collaborated with a music teacher. Like in our previous work, we said that it's possible to compare the dynamics curves, and we also carried out a case study wherein we collaborated with a music teacher, annotating the scores with dynamics markings and comparing it to the loudness features derived from audio. And we did find close correlation. So what we thought, okay, this research direction looks promising. Can we further annotate more scores with dynamics markings, and would the results extend? So keeping that in mind, the first research question that we try to address through this work is, given musical dynamics annotated by a music teacher, like piano, forte, and so on, can we compare the annotations with loudness features derived from audio, which I said earlier. And further, we also wanted to see some kind of in our previous work, we compared it with professional renditions, some karaoke renditions, which are exactly imitating the performance of the teacher, or not just the teacher, or any reference recording. So we also wanted to see, can we take some karaoke renditions, which are part of several applications that people use. So can we sort of take some student renditions, do a similar comparison, and find is the professional rendition better than the student rendition, and so on, and so of using this loudness metrics. For further details, how the data was collected, what was the methodology, of course, there's lots more details that goes into the methodology, there's synchronization, source separation, all the details. Come to my poster, once again, I'll be there, and we can speak more about the results. Thank you. Thank you.